Welcome to Lab 5, Tension Bending with Strain Gauges. The goal of this lab is to evaluate tension, bending stress modules, and Hooke's law. For your convenience, we have put the formulas on the board behind me. Also, the goal of this lab is to determine material modulus of elasticity represented by E from tension and bending tests, and to introduce the use of strain gauges. In this strength of material course, normal stress is one of the two most fundamental parts of this course, and it can be developed in one of two ways. 1, tension due to normal stress, or 2, from bending. The value of stress is calculated through the equation sigma equals axial load over cross-sectional area, which measures the force being applied, and this equation can be used for pure tension. In this lab, one sample will be loaded in pure tension and strain will be monitored with strain gauges. Using Hooke's law, stress can be calculated from the experimental strain values. The calculations for stress can then be compared with the values determined from the formula sigma equals axial load over cross-sectional area. Through stress bending, the beam will go through a 4-point loading configuration. Using appropriate formulas for longitudinal strain in a beam, stress values can be calculated from the measured strain and compared with the expected values of stress using the equation sigma equals bending moment over moment of inertia.
For your materials, you will be using a 6-inch 1018 steel flat tension specimen with 2 strain gauges and a 14-inch 1018 steel beam with strain gauges. For your pre-lab, several calculations should be performed before the lab exercise is performed. See the pre-lab worksheet and determine the tension and bending values for the specimen. Note that all force measurements will be in units of pounds. Strain measurements are dimensionless but will be recorded as microinches per inch. All stresses are in pounds per square inch, and the modulus of elasticity also has units of pound per square inch. Material properties for steel to use in predictions are E. Young's modulus equals 30 megapsi, V. Poisson's ratio equals 0.29, allowable bending stress equals plus or minus 16,000 psi, and allowable shear stress equals plus or minus 8,000 psi.
For the procedure, the teaching assistant will perform a simple tension test on the Instron Universal Tester using the 1018 sheet metal specimen. 2 strain gauges are mounted parallel to the direction of pull and should report the same values. Their results will be averaged for greater accuracy. Instead of allowing the Instron machine to continuously record force and extension values, the testing will be paused multiple times as the load increases to record the load and strain values from the gauges on the attached data sheet. That data will be used for further analysis in the lab report. The teaching assistant will perform the following. After the specimen is mounted and ready for testing, the strain gauge values will be balanced or zeroed. The applied load will be increased in approximately 6 increments to the predetermined maximum load. The load and strain values will be recorded for each increment. The zero value of the gauges will be recorded at the end of the test. For the bending test, the beam will be subjected to what is called a 4-point bend test. Strain values on the top and the bottom of the beam at midspan will be measured throughout the testing. As with the tension testing, the test will be performed in increments up to the predetermined maximum load. The same 3 steps will be performed as outlined in the tension testing section. And for the data analysis and discussion, refer to the handout.